Hello students, welcome back. So now we are going to talk about the Xilinx Vivado design suite. We are going to talk about the whole platform and how to design and simulate one simple Verilog program using this software. So in this video, we are going to talk about that which icon we should click to open the Vivado, then how to generate a new project, how to generate RTL schematics, design and different simulation options, and we'll also see how can we access the FPGA board through the Vivado design suite. So all of this we are going to do using our complete platform called Xilinx Vivado design suite. So let us get started right away on the software itself. So as we had discussed in the installation video, you will be getting two icons. One is Vivado HLS and one is only Vivado. You have to click on Vivado. Double click and wait. It will take a few seconds to load. Do not click again and again because it will open multiple instances of Vivado. So only one double click and then you have to wait. So now the software has opened. If you have already worked with Vivado, your recent projects will be listed here. Otherwise, it will be a blank screen for the first use. Now we will create a new project. For that, you have the options here. You can create a project. If there is any existing project, you can open it, or you can open the example projects. These things on the lower side are for the advanced users, and you have documentations and tutorials and everything else in the learning center. So we click on the create project and a wizard will open which will guide you through the project creation. So first of all, we'll go to the next. Here it is suggesting you a name. What are the rules that you have to follow while naming? We'll discuss them in detail when we talk about the Verilog coding, but the simple rules are: it should start with an English alphabet, it can have alphabets plus numbers and underscore, nothing else, and your project location should not have any space. So if you are having a folder named test projects, do not name it like two words, test and projects. Name it test underscore projects. So in the whole path, there should not be any space. Now we go to next. We are going to select RTL project. Then it is asking whether you want to create the files right away. We say no, we'll create the files later, and we just go to next. And we will also skip adding the constraint files. Now here we are being asked to select an FPGA board. FPGA boards can be identified with their part numbers, which is written on the back side of the FPGA board, or by the names. If your aim is only to learn the Verilog coding, in the beginning we are going to do that. Then you can select any random board. But if you really want to implement your circuit on an FPGA board, then you should search and select the relevant one. So right now, randomly we can choose any one and go to next. This is the summary that we have, and we finish. Now it is preparing the project. The project will have the initial information about the board, the language, the simulator. By default it is Verilog, and the simulator is also Verilog, so you don't have to worry. See, you can see here target language is Verilog, simulator is mixed. Mixed means both Verilog and VHDL are supported. So by default most of the things are fine and well suited for us. Now if we look at the options on the left side, here we have the project manager where we can create new files Here we have simulation option, RTL schematic generation options, synthesis, implementation, and then finally generating the bit stream for FPGA uploading. This is the process that we follow for digital system design, and these options are given in the same order. First we will add the source, write a Verilog file. We are going to simulate it. We can generate RTL schematic. Then we will synthesize, implement, and then go to FPGA. Right now in this video, we'll talk about adding and creating a Verilog file and generating the RTL schematic. In the next one, we'll talk about the simulation part. So click on the add source. There are three types of sources. Constraint is the constraint file for FPGA. Design source means your Verilog file, and simulation means the test bench. So we choose the design source. Go to next. If you have a file, you can add it by browsing, but we don't have. We'll say create file. Give it a name. Let us say test1 or anything that you can give. Click on the OK, and now you can see this file is listed here. Go to finish. Now we are being asked that in your file, do you have any ports, inputs and outputs which you want to define now? So we'll say okay, fine. I have A, B, both of them are input. You can change the direction if you want by clicking here. I say let me take one more input, C, and I take one output as Y. 3 inputs, 1 output. Go to OK, and now the project is creating a sample file for the module test1, and it is created here. Double click on this and the file will open here. It is having the initial information like this is module declaration, the name of module, these are the ports with their directions, and end module. That means if I enter like this, I can write my statements here. And I write a simple statement, assign y is equal to, I take brackets, A and B, and then we take an OR with C. Don't worry about these symbols. How am I using them? When we study about the Verilog coding in detail in the next module, we'll talk about these in details. Right now, we can understand that the ampersand symbol is representing AND gate and 2 vertical bars represent the OR gate. You can press Ctrl S or you can click this symbol and save the file. As soon as you save the file, this updating means it is checking for the syntax also. If there is any syntax error, it will show the error. So let me make a small mistake. I am removing this semicolon and I save it again by pressing Ctrl S. And now when it is going to update, it is showing that the file is having syntax error, and this is the file test1.v, and there are 2 errors. You can click on this number 2 and here the errors will open. It is showing that in your file line number 32 test1.v there is an error near end module. So this is line number 32. Go before that, and whichever is the line before that, there is the error. So if I put semicolon here and save it again, now it is updating and we will see that these 2 errors are gone. So this is how you can write your code and you can check the syntax. Now we want to convert this file into a circuit, a schematic. For that, the very simple option is go to RTL analysis, click on open elaborate design, left click, all the clicks on this side will be left click. Left click and click on schematic. When you click on schematic, there will be some information given to you. Click on OK and wait for the schematic to be generated. It can take few minutes, not minutes, a few seconds for sure, and be patient. Now the software is converting your statements into the circuit elements, and it is going to join them and present a logic diagram in terms of logic gates and other digital modules to you. So students, we can see that the schematic is generated. A and B, they are connected with one AND gate. The output of this AND gate is connected with another OR gate where the second input is C, and finally Y is my output. This was a very easy and simple circuit, and we can manually cross check if all the connections are fine and whether the circuit is going to work fine or not. If the circuit is more complex, then how do we cross check whether it is functionally correct, or if there is any misconnection, any wire is missing? All these things can be tested using simulation. So students, in the next video, we'll continue with the same example and talk about the simulations using the Xilinx Vivado. We'll see how to generate different test cases using the waveforms and cross-check the functionality of our system. Keep learning. Thank you.